As we said, till now we were using only solid mesh. We were using only solid finite elements, and now we're going to show how we can and when we can use a shell finite elements, how we can create a static analysis of a shell body. So when can we treat an object as a shell? So body in general can be considered as a shell when the shear deformation is not significant. So when we create a study of the shell body, we have two basic formulations. We can go with thin plate formulation and we can go with thick plate formulation. When we use thin plate formulation, the shear deformation is neglected, and thick plate formulation takes account of shear deformation. So thick plate formulation is more accurate, but is more sensitive to mass distortion, and it's more sensitive to high aspect ratio. We should avoid to use thick plate formulation when we have a small shear deformation. In contrary, we should use thick plate formulation when the shear deformation is expected to be important. So we have two ways how we can develop and how we can study a shell body. So for example, we can have a surface body and then we can treat that body as a shell body. As well, we can have a sheet metal body and then we can treat that body as a shell body. So in this chapter, we're going to show how we can study a shell body by using surface and sheet metal. So we can develop a CAD model by using surface tools. And then software automatically creates a shell by uniting all the surface bodies. And user has to define the type of the shell, the thickness and the offset. And all of those things we're going to show on our real example. As well, the thickness can be different on different parts of the body. As well, we will have to define the contact constraint, and that's necessary when we have a surface body. As well, we can develop a CAD model by using sheet metal tools. And the thickness, we don't have to define. The thickness is extracted from the thickness of the sheet metal. And we don't have to define the contact constraint. All of that we're going to show on the real examples. So we're going to have the same model with the same dimension, and in the first case, we're going to develop that model by using surface tools. And then in the second case, we're going to develop that model by using sheet metal tools. And then we're going to use shell finite elements to create a static analysis.